Hi, I'm Yunqin, and today I'm going to make a presentation with my partner Xicun, and we are going to talk about graphic analysis as the final project topic. Before the presentation, I would like to talk about the reason why we choose this topic, graphic analysis, from those several given different topics. Because we think that graphic analysis is a very useful way to help us convert the different data and digits into graphs to help us analyze those data in a more simple and visible way. And we all know that the graphic analysis has a really huge impact on the real world and business analysis. Because you can see that if we show something in graph or in diagram, it could be more visible or more simple to help us understand the topic or the digit. So let's talk about what is graphic analysis. As you can see, graphic analysis could be used to determine the strength and direction of relationships between objects in a given graph. And the graph is also could be used to represent a particular relationship between certain objects. And in our project, we're gonna do the graph analysis towards two different topics. The first one is the Quicker, and another one is the Facebook.
Okay, next I'm gonna talking about the business analysis using in graph theory. So since most things around the world could be applied by using graph. For example, like social circle, traffic flow, and neural networks, and so on. So all these real problems could be represented by graph, and people are able to analyze such problems by using graph analysis. For example, like sales staff want to optimize the sales route, so graph could help them reduce cost and reduce travel time for sales. And similarly, for a supply chain, graph helps them to determine the best route for delivery trucks and identify the location of the delivery center. And another example is telecommunications companies. They typically using graph to understand the number and location of base stations, so to ensure maximize the coverage of the signal. So graph analysis are using in every field. In our project, we will mainly focus on the social network analysis, because it's one of the simplest way to understand graph. Meanwhile, it's one of the most common area that graph used in. As we all know, graph is composed by vertices and edges. Similarly, social networks can also be represented abstractly by nodes and links. In the following analysis, we will mainly discuss two issues. First one is which the most important node in a social network, and second one is what's the attribution of these nodes. There are two different networks data sites we used in our project. First one is about Quicker. That's we found by ourselves. And another one is about Facebook. This from the references provided by the professor. We would like to find the most influenced person and different cluster through social network analysis. Let's see the first data site, Quicker. Before Facebook, people have nice understand about the social network. but they also need to communicate with each other. Thus, there are many society of friends. Quaker is one of this society of friends around Protestant Christians. You can see in our data site, there are totally 119 nodes and 174 edges. So each node represents a particular person in the social network. And inside the nodes, it will include the information of that person. And edge represents the relationship between two people. If there is an edge between two nodes, it means these two people are familiar with each other. By the way, we can see an average degree here is about 2.9. So the degree of the vertex is the number of edges with an end node. In social network, it represents the number of friends that the person has. In exploratory data analysis, here we just add some attributes for the node, cause so far we just established the node and we don't add anything inside the node. So here we add 6 attributes for the node, including name, historical significance, gender, birth year, death year, and such ID. It's just help us to find the node and find the information of that people here. Just see the data might be abstract. So let's see the graph. And here is the graph. We will analyze this later. To analyze this graph, it's unlike the previous live we did. There is no module here, or we think the graph analysis is a kind of module in data science to analyze this data. Here we considered 4 graph analysis methods as the module. So first is network density. So it describes the ratio of actual connection to all potential connection in a network. So potential connection means the relationship that might exist between 2 nodes. And the actual connection means there exists a connection between 2 nodes. This represents the distribution of nodes. Let's see our Quaker State site. The network density is about 2.48%. It means in our network, the distribution of nodes is not very dense. So there are still some nodes far from the center. As a whole graph, the nodes are not centralized. Shortest path is to calculate the shortest path between 2 nodes. So it's usually applied to automatically obtain the directions between 2 physical locations, like using Google Maps to find the shortest driving directions. But in social network, it's usually to find the friends. Like in our case, if one people want to know another person, how many introductions does he need to get to know another person? So here is 2. It means he could know the destination here, like the person he wants to know, just by the introduction of one person. And diameter is a new measure in graph analysis. So it means the longest path of all the shortest paths. So it's usually help us to understand the size of the entire network. So here, the network diameter is 8. So it means if one person in the network wants to choose another person, it will at most need 8 introduction of people to know another person. So it's just briefly give us an understanding of the size of network, but it's not as accurate as network density if you want to know the size of the network. Centrality is to measure the node's importance. There are many ways to calculate the centrality, such as page ranking and degree and bitterness. So here in our project, we just focus on degree and bitterness. Degree centrality it measures the number of relationships a node has. If a node, the more relationships a node has, the higher centrality it will be for this node. In our case here, George Fox has 22 degree, so it might be the most important person in this network. It might mean that he would know 22 people in this network. So he knows the most people in this network. With bitterness centrality, this measures the number of shortest paths that pass through the node. Note that most frequently lie on shortest paths have higher bitterness centrality scores and are the bridges between two different clusters. It's often associated with control over the flow of resources and information. So here, if a person have the higher bitterness centrality, it usually means he has more power in this network, or probably has a higher status. So overall, degree centrality and bitterness centrality are two different measures, but both of them measures the importance of a node. Community detection is similar to clustering. So in our project, there are also many measures to determine the communities. And in our project, we will using UMN modularity. This calculates the relative density in our network. And if a community has higher density, it might form an individual community. That means the nodes within this community might have similar information or behaviors. Here we're using another measuring to calculate the centrality, which is eigenvector centrality. It also helps us to understand the influence of the node in the modularity. So in our example, we can see that these 5 people might be divided into 1 communities, and it means they might have some similar behaviors. And in fact, based on the information, they all spend a lot of time in the US, and maybe in Quaker they have the similar status, and maybe their jobs in Quakers are also the same. Here we just draw a beautiful graph that present community detection in our network dataset. So the different color represent different communities, and probably the nodes within the communities might have the similar information or behaviors. So because of that, they form communities. They form a community.
I am Yunqin, and now I'm going to talk about another chosen data set about the Facebook. As well known, Facebook is one of the most famous social network companies around the world, and we collect those informations from the Facebook service company. And in our given data size, you can see that we have around 4,000 nodes and 80,000 edges, which means that in this data set we have more than 40 people to do some research, and around 80,000 relationships between those people. And after the introduction part, you can see I draw the graphic here, and every red point is every single user, and the black line means that the black line between every single point means that they have a friendship relation on Facebook website. And now I'm going to talk about the models, just like the different strategies which we use in this given data set. First, let's see about the network density. You can see the code that we define a variable named density1 and use a function nx.density to get the density of the previous given data sets. You can see that the result is around 1.08%, which is not a really huge number. After seeing the previous graph, you may ask that, oh, I see that the density should be very high, because you can see that every single point is really close to each other in somewhere in the diagram. But actually, after the result showing that it's not a very high density diagram, because that the actual connection in the data set is not really the same as you can see here, and it's not as many as potential. So for the shortest path, that the Facebook's data set is really different from the previous one. For the previous one, each single node stores different information in that, and we could find the shortest path between every single node. But in the Facebook one, we do not have any information stored in every single node. So we do not apply for these strategies on the Facebook data set. But from the diameter shows that the diameter is 8, and we can measure the size of the network based on the given diameter 8. Now let's talk about the centrality. So in this data set, the centrality is a kind of importance, which means that we could find some people who have the huge impact on others on the Facebook website, and we pick top 10. As you can see here, we list the top 10 nodes by degree, and the first one is the people who has the number 107, and the degree is 1045, and this is the most significant people from our chosen data set. So as you can see from the graph, we dark every single node and marked the top 10 nodes in red. So in this diagram, you can see that the top 10 chosen nodes, which means that the top 10 person who has a huge impact on Facebook has strongly connected with other nodes. You can see the black lines has a high density around the chosen 10 red nodes. Now let's focus on the community detection. So community is a kind of really important part in Facebook, and I think the people belongs to the same community maybe have the same similarities, and they cluster together with each other and build a kind of the group. As you can see from the graph, we marked every community or every cluster by different colors, and you can see that every edges has really close distance between each other in a single community. That means that those kind of people belong to a same community, and they have a lot of similarities between each other. But on the other hand, we could not exactly know that what does each community represent. But we know that the people belong to different communities have strong similarities with each other. That is the most important things which we could find from this kind of graph. So in our project, we did some research on graphic analysis and using two kind of given data sets. The first one is the Quickers and another is Facebook. And we know that we have 4 different stages in the project. There are network density, shortest path, centrality, and community detection. So in each given data set, we use different 4 ways to do this research on different 4 topics and find some results and show them in diagrams or in graphics and get some different conclusions. We both find the most important people in the given social network data set and find some different communities or clusters in the 2 different given data sets separately. And in the future, we may also use 2 kind of different stages to modify our projects. They are BFS and DFS. And I think the BFS algorithm could be used to find the people within a given distance, and it is really useful in the social network community, I think. So users could find their neighbor, their friend, their classmates easily around campus by using the BFS algorithm. And the DFS algorithm could be used to find a specific person in the given social network. Something like we could search some person by their ID or by their email address and by their phone number if we could apply DFS algorithms in our projects in the future. Finally, here are some links which we use during our presentation and our final project part. Thank you so much.